Say when.
When?
Oh, hello there. So I heard you wanted to learn about nested subroutines. Well, you've come to the right place. You see, a nested subroutine is just like a normal subroutine, except it's called from within another subroutine. When writing a nested subroutine, you have to handle all the same sort of issues as you do when writing a normal subroutine, plus one or two more. One thing that nested subroutines and normal subroutines have in common is a specification. Specification tells the user how information is entered into the subroutine, how information comes out of the subroutine, and which registers the subroutine uses along the way. Now, it's very important not to use any registers that you do not state are being used in the specification, because if the user is also using these registers and doesn't expect them to be overwritten, they will be filled with what is, to the user at least, total garbage, and that can have earth-shaking effects on your program.
When writing a subroutine, you may not know which registers are important to the caller, so you may end up saving registers unnecessarily. If you're not sure if it's important, you can just mention it in the specifications. The caller knows which registers are important, so if it sees them in the specification, it can save them then. The other thing to be careful about is when you have nested subroutines. Suppose subroutine 1 uses registers 1 and 2, and subroutine 2 uses registers 3 and 4. Now, if subroutine 1 calls subroutine 2, it's actually using all 4 registers. Now, it can either save register 3 and 4, or it can just mention them in its own specifications.
When calling a subroutine in CLX, a jump and link command is used. After the subroutine is finished, a jump return is used to tell the program where it was before the subroutine, so it can get back. This works by using register 31, which is set by the jump and link command. In nested subroutines, because the jump command is called twice, R31 is modified 2 times. This causes a problem because after the second subroutine is finished, the 31st register is still set to jump to the first subroutine, creating an infinite loop. To avoid this, a variable is used to save the 31st register before the nested subroutine is called. After the nested subroutine is called, the variable is loaded back into register 31, which fixes the jump and avoids an infinite loop.